Hello, we will be looking at our worksheet quiz number 9A, which will have the first 10 problems, and we'll do the next 10 in a second video. I will give you an explanation of the problems, and then I'll probably give you another worksheet just to see how you do if you understand what we are going over today. But as usual, if there are questions after we go through this, please give me a call and we can get that cleared up. Okay, let's look at question number 1. It's about John who's delivering newspapers and he receives 7 cents per newspaper. Now, 7 cents translates to 7.07, 7/100ths of a dollar. Now, he receives a bonus of $5 each day that he has no customer complaints, and he is a good worker, and he never misses his route. So, let's develop the function that represents the money he makes on one day on his paper route. X will represent the number of newspapers that John delivers. Now we can use f of x or y, they are equivalents, to equal the money that John makes on one day of his paper route. So what he makes is 7 cents per newspaper and $5 is his daily bonus. So if we combine those two together, it could be either y or f of x, 0.07 cost he makes per newspaper times X, the number of newspapers that he delivers, plus the $5, which is the bonus, and that answer is C. Now notice this looks familiar. This is just like our slope-intercept equation, where we have y equal mx plus b, where m is equivalent to 0.07 and 5 is the y-intercept, or the initial amount. Okay, let's look at number 2. Number 2, we have a basketball game. Tickets are sold at the door. An adult ticket costs $5. Student ticket costs $1.50. Now, we will let A represent the adult tickets and S represents the student tickets. And we'll define the expression that represents the amount of money collected at the door for the ticket sales. Now, we know that total is equivalent to adult tickets plus student tickets. So $3, the cost of an adult ticket, times A that represents the tickets, plus $1.50 times the student tickets is equal to the total ticket sales, which is answer A. Okay, let's look at number 3. Number 3, we have Julia having $22 to spend on chewing gum and the juice. The cost of the chewing gum is 75 cents per pack, and the cost of juice is $1.25 per bottle. Now, she must buy 7 packs of chewing gum. Now, we are to select the inequality that represents the maximum number of bottles of juice that she can buy. And we will let B represent the number of bottles of juice. 0.75 times 7 as the cost of the chewing gum that she must buy. $1.25 times B represents the cost of the juice that Julia can buy. And $22 is the amount of money that she can spend. The sum of the gum and the juice must be less than or equal to $22. And how do we show that? Sum is plus 0.75 times 7, that's the chewing gum that she must buy, plus $1.25 times B, the number of bottles that she can buy, and that must be less than or equal to $22. And that's what the symbol here is, less than or equal 22. The answer is A. Okay, let's go to number 4. Number 4, we're given a population of 9.05 million, and the rate of the population growth is 3.1% each year. Now, this is an exponential growth, and it's an increase because we say the rate is 3.1% each year. So we want to find a function that can be used to find the population 7 years from now. 7 years from now represents an exponent. Now the 100%, that's equal to 1. If we convert that to a number, that's 1. That's the population factor. Now if it's increasing by 3.1%, that means it's going up by 3.1% each year, and that's represented by the decimal point 031. Now remember, you can divide the 3.1 by 100, or you can shift the decimal point 2 places to the left. Now this must be added to that population factor of 1. As I said before, the 7 years from now is the exponent that represents the growth. Now the 9.05 million we can write in scientific notation as 9.05 times 10 to the 6. The decimal point is here. We shift it 6 places to the left. We get 9.05, and that 6 places is represented by the exponent 6. So the function would be the population, 9.05 times 10 to the 6, times the 1 factor plus the increase, 0.031, and all of this is raised to the 7th power, which is the 7 years from now that we are representing in this function. And that answer is B. Okay, let's go to number 5. Number 5, you're given 2 football players' earnings, McGee and Fitzpatrick. McGee earns $0.005 million more than Fitzpatrick. More than means an addition. That means you add this $0.005 million to Fitzpatrick, and you get McGee's earning. The 2 of them earn a total of $3.95 million. Now, you are to select a system of equations that could be used to determine the amount each player earned. So, McGee plus Fitzpatrick, 3.95. That's the earning of the 2 players. McGee equals Fitzpatrick plus 0.005. That represents McGee earning 0.005 million more than Fitzpatrick. So the 2 equations are M plus F equals 3.95 and M equals F plus 0.005. Now this equation is the same as F plus. This equation, M equal F plus 0.005, is the same as F plus 0.005 equal F. Notice the only difference, we put the M on the left here, and here we put the M on the right. The answer is D. Okay, let's look at number 6. We're given a graph showing the temperature versus time, and we have defined the time interval with the greatest rate of change. Now, you know what rate of change? Rate of change actually is slow. Okay, so we can set up a table of our time interval our temperature change, and the average rate of change. And that's on your graph. They give you a line, and each line has the time, the temperature change, and the time interval you can see on the X line of the graph. The temperature change is on the Y line. So let's look at the first interval. From 0 to 1, temperature goes from 700 to 200, all right? Difference between 700 and 200 is 500. Difference between 1 and 0 is 1. So the rate of change, 500 over 1, is 500. Next interval from 1 to 1.5, and the temperature change from 900 to 700. 900 minus 700 is 200. 1 minus 1.5 is 0.5. 200 divided by 0.5 is 400. That's the same as 200 divided by 1/2. You invert the 1/2, and it's 2 over 1, and 2 times 200 is 400. Next interval, 2.5 to 5, temperature change 1640 to 300. The difference between 1640 and 300 is 340. The difference between the time interval 5 and 2.5 is 2.5. When we divide that, we get 136. The last time interval is 5 to 8. Temperature change 1640 to 1800. Difference between 1800 and 1640 is 160. Difference between 8 and 5 is 3. 160 divided by 3 is 53. So the time interval with the greatest rate of change is the 0 to 1 that has 500. And that answer is A. Okay, let's go to number 7. Number 7, you're given two polynomials and you to find the difference. A, 3x squared plus 5x minus 6. B, minus 2x squared minus 6x plus 7. What is A minus B? So we put A here, and then minus B, which is here, and then we do our subtraction. But notice here, minus minus will give you plus, minus minus give you plus, and minus plus will give you minus. Now we can add them. 3x squared plus 2x squared is 5x squared. 5x plus 6x is 11x. And a minus 6 and a minus 7 is a minus 13. So your answer is B. Okay, let's look at the next question, number 8. We're given 4 tables of f and f of x values. Remember, f of x is the same as y, okay? Now we want to determine which table represents a linear relationship. Now when the x value changes constant, the y value changes by the same amount, then the relationship is linear. So if you look at the tables, the only relationship where the y value changes by the same amount is C. That is, if you add 2 to the previous value, you get the next value. So minus 3 plus 2 is a minus 1. Minus 1 plus 2 is plus 1. 1 plus 2 is 3, and 3 plus 2 is 5. And that's the C table, where we see that the y is changing by the same amount. And that's characteristic of a linear relationship. Now let's go to number 9. John has nickels and dimes, for a total of $1.25. We want to find an equation that could be used to determine the number of dimes that he has. He has 4 more nickels than dimes. we let X equal number of dimes. Nickels amount plus dimes amount equal $1.25. Now a dime is 10 cents. That's 1/10 of a dollar, which is 100 cents. A nickel is 5 cents. That's 5/100ths of a dollar, which is 0.05. Now we were told that he has 4 more nickels than dimes. That means X plus 4 equal number of nickels. Now, we can write our equation, 0.05 times the number of nickels, X plus 4, and X is the number of dimes, 0.10 times X, and this must add up to $1.25. All right, this is the number of nickels, X plus 4. X, they told us, was the number of dimes. So the answer is B. Now, let's go to number 10. Number 10 deals with cost, revenue, and profit. Profit equals revenue minus cost. Revenue is what you make when you sell something, and cost is what it costs to produce that something. All right? So cost of X is given as 300X plus 250. R of X, which is revenue, is minus 0.5X squared plus 800X minus 100. The profit, P of X, is revenue, R of X, minus cost, C of X. So if we substitute in our cost, we first substitute our revenue here. That's the minus 0.5X squared plus 800X minus 100. And then we subtract our cost, which is 300X plus 250. So that's our equation here. Now, let's combine like terms. So we only have the X squared once. So we just bring that down, minus 0.5X squared. Now, we have 800X and we have 300X. So 800X minus 300X. Those are combined. And then we have a minus 100 and a minus 250. So what do we get? The profit, P of X, minus 0.5X squared. 800X minus 300X is 500X. Minus 100 minus 250 is minus 350. And our answer is B. Now, as usual, if you have any questions on any of these first 10 problems, give me a call and we can go over your concerns. I will create a second video with the questions 11 through 20. And I thank you for sharing this session, and I hope this makes it clearer to understand those problems on your worksheet. I will probably give you another supplement worksheet just to find out if you really do understand how to solve these type of problems before we go to our next worksheet. So I will see you on the next session.